Welcome to arttechshares.com. Video tutorials. Modeling using linear function. You can see there are two key elements involved in this heading. One is modeling, the other one is linear function. First, we focus on modeling. So, what is modeling? Modeling has many meanings, but in mathematical sense, we consider it as converting a function or an event into a mathematical formula. Hence, it is also referred to as mathematical modeling. Under this topic, we learn how an event is converted into a mathematical model with simple and easy steps. Let's consider this simple example. Assume that every day you ride your bicycle to school from your house. The distance between your house and the school is 2000 meters and it takes 40 minutes for the ride. Also assume that you maintain a constant speed. This means that you never change your speed and never stop anywhere between your house and school. Tomorrow you will start your journey at 7:30 a.m. So your friend wants to know at 7:45 a.m. whether you will be passing the lake or not. So the lake is situated halfway of the total distance. This means that it is 1000 meters away from your house or 1000 meters away from your school. So how can your friend predict this? At this point, we have to collect all the data and write it down as shown below. So at this point, we need a method or a function to predict whether you will be passing the lake or not. So as we only know the distance and the time, we have to use this data to manipulate a formula or a function. So what we do here is that we take the information given about your daily routine and convert it into a formula, mathematical formula. This process is called modeling. As you can see, we can let letter D as distance, T as time, and V as speed. The unit for speed is meter per second, but in this case I use meter per minute. So the speed formula is given by speed is equal to distance divided by time. So therefore we can write V is equal to D over T, that is 2000 over 40. So it will 50 meter per minute. So this shows that you travel 50 meters per minute. It is constant, therefore we can write the formula as D divided by T is equal to 50 meters per minute. So we have to rewrite this formula. We have to take the D as subject. To make the distance as subject, this means what is D is equal to? So we have to rearrange the formula. So we have to eliminate the T in the denominator. So what we do, we have to multiply the equation by T. So D divided by T, so we multiply T in both sides. Otherwise the equation wouldn't be balanced. Okay, I will show you an easy way later. Now we can cancel this T and this T, and we will get D is equal to 50 T meters per minute. This is the relationship between the distance, constant speed, and the time. On the other hand, we can say this is the mathematical model of your daily travel routine to school. Now I hope you understand what modeling is. So what we did here, we collected all the information and using the simple relationship between speed and distance and time, we formulated this above formula. So what can we do with this? Using this model, now your friend can predict where you will be at 7:45 a.m. tomorrow. So the time difference from the beginning of your journey to 7:45 a.m. would be t is equal to 7:45 minus 7:30. So there is 50 minutes. I hope you understand how to calculate time related calculation. So substituting this 15 minutes into the formula, we will get 50 times 15, and minute will be cancelled, and is equal to 750 meters. So a good practice is always use the units of each elements, and it will help you to determine the unit of the final answer correctly. So I will add a tutorial about units and dimensions later. So this answer shows that at 7:45 a.m. tomorrow you will be 700 meters away from your home. This means that you will not pass the lake at that time. Now carefully look at the formula. You can understand when you change the value of t, the d changes. That means the distance changes. Clearly, in this equation, the distance changes as the time changes. Therefore, the d is called a dependent variable. We can select any positive value for t, and the time t is not dependent on any other elements. You can select whatever you want. Therefore, the time is called as an independent variable. So you can select the time. Now pause this video and try it yourself to find how far you will have traveled by 8 a.m. tomorrow. So the answer is t is equal to 30 minutes and d is equal to 1500 meters. I hope you understand the calculations, and this is only a simple example, and you will learn more complex modeling later. So recap time, what we do a similar situation like this. So gather information or data, find all patterns which could be substituted by mathematical equations. Together convert it into a mathematical formula. Using this formula or model, we can predict a future event. Once again, what we do is gather information or data, find a pattern using simple fundamental equation as we use speed formula, and together convert it into mathematical model. Using this model, a future event will be predicted. So rainfall model, population model are some of the examples. I hope you understand what modeling is. Now consider a different situation. If a group of data is given, what can we do? Consider the data given in the table. What can we do with this data? Can you find the relationship between two sets of data by looking at it? Can you find any relationship between two rows of data? So we can't find a relationship just by looking at it. What we do? So we can plot them by choosing proper axis. So in this case, the time is independent, therefore it goes to x-axis, and as distance is dependent variable, it goes to y-axis. Now we have to choose the points, and 0, 0 and 5 to 50 here, and 10, 500 and 15, 20, 25, 30, 35, 40. So by connecting these points, we will get a line. It is a straight line. On the other hand, we can say that the output of T and D is a straight line. So what does this tell us? This tells us that the relationship between the two data is linear. On the other hand, the behavior of output related to the input is linear. Or we can say that as the input values increases, the output values increases linearly. Or we can say D is proportional to T. When we look at the table, we don't see any relationship between the two data. Or when we plot them one against another, we will get a pattern. This could be a straight line or curve or combination of any. In this case, we got a straight line. You might get some pattern like this. Maybe if you plot some different data, you may get a plot like this. Give me a second. So yeah, like this. So you can't put this into one category and call it by a name such as straight line or curve. For now, assume that we only know two types of graphs. One is a straight line, the other is curve. Can we identify lines and curve? Of course, yes. There are two segments of straight lines and one curve. So we can separate them as this is a straight line, this is curve, this part is a straight line. Now we can find the equation for the straight lines and the curve. By combining them together, we can create the model for this pattern. The actual modeling for such a complex pattern may require other conditions as well. The only thing I need you to understand is models can have a single or combination of straight line, curve, or any other pattern, and these are represented by mathematical equations. So now we have this pattern. Let's see how can we formulate the mathematical model for this pattern. The relationship between the given data is a straight line. Therefore, we have to determine the equation for the straight line. So this is the model of the given data. So the general form of a straight line is given by y is equal to mx plus c, where y is dependent variable, x is independent variable, m is gradient, the slope of the line, and c is y-intercepts, where the line crosses y-axis, and then the gradient is given by m is equal to y2 minus y1 over x2 minus x1. So that means we need 2 points from this graph, and yeah, I choose as x1 y1 this point and x2 y2 this point, and yes, substituting this value, though I will get 50. So you can choose any other 2 points and check your answer. If you don't get the same answer, that means m is equal to 50, that means you are making mistake and try it again. So there are no y-intercepts, therefore c is equal to 0, and substituting m is equal to 50 and c is equal to 0 in y is equal to mx plus c, finally we get y is equal to 50x. So you can change y as d and x as t. Then the formula would be d is equal to 50t. Do you remember this? Yes, of course, this is the similar formula we got in the first section. I hope you understand this process, and remember, a linear equation is an equation of a straight line. Once again, a linear equation means an equation of a straight line. Recap time. What we do for this similar situation. First we determine XY axis. Usually we choose X axis for independent variables and Y axis for dependent variables. And then we plot the data and see the pattern. From the plot, determine the type of the relationship and find the equations or find the mathematical model. Let's learn how to determine which one is the independent variable and which one is the dependent variable from a group of data. If there is an equation given, example d is equal to e to the power of negative 3t, where t is time, and then you have to select a value for time in order to find the value of d. So you can repeat this process for various values of t and tabulate. In the other words, we can say that d values are against chosen t values. As you choose the t values, it is determined as independent. As d values depend on t values, it is determined as dependent. Now, you know which are x values and which are y values. If a table like this is given without mentioning axes, what can you do? Can we use the first row as x-axis and the second row as y-axis? Because in the previous example we used that first row as x-axis and the second row as y-axis. Can we do that? Or do we need any other strategy? Let's see. Just carefully observe the values in the rows. So the values in row 1 don't have a constant interval. That means if you subtract one value from another, you don't get a constant value. You can see that here. So these two values are different. So it can be seen that the values are outputs of a function. So these values become some kind of output of a function. This means that you can't select these values randomly. You can't select this value. So it is some kind of output. Do you understand? But in row 2, if you do the same process again, row 2 have a constant interval which is 2. So 2 minus 0, 2, 4 minus 2, 2. That means the values can be selected as the input of the function. Therefore, the values in row 2 are independent, while the values in row 1 are dependent. On the other hand, we assume there's a function there, so we need a input. There's a function, there's an output. So inputs are independent, outputs are dependent. So H should be in y-axis and N should be in x-axis. Is it clear? So you choose independent variables. I hope you enjoyed the video and see you in the next tutorial. Thank you.